In this video, we're going to take a look at the key features of polynomial graphs. So make sure you put today's date in the top corner. So let's just take a look at some of the key features that we've talked about for other graphs, for functions, and for quadratics that we're going to keep using the vocab for polynomials. So one of the words is domain. So remember, domain is all possible x values. That's all the possible x values in a function. The range, which is all possible y values. What's called zeros. These are the x-intercepts of a graph, so where the graph is crossing on the x-axis. Sometimes it's called roots. And then something new that we're going to talk about for polynomials is what's called increasing and decreasing intervals. So we'll start first with increasing interval. So an increasing interval is a portion of a graph where the graph's value is moving in a positive direction for the y coordinates. So positive direction in a graph. And then decreasing interval is the inverse or the opposite of that. That's where you're moving in a negative direction for your y values. Your y values are decreasing. So as we take a look at some polynomials, we're going to graph them and identify these key features from the polynomials. So let's start with a couple examples. So our first example is we're going to graph an equation of a polynomial. So we'll just label this number 1. And here's our polynomial. Y equals x cubed plus 6x squared plus 9x. Remember, a polynomial is when you're adding different terms together that have different powers. Standard form means you put the polynomial in order from highest exponent to lowest exponent. So for this one, we can take a look at what its graph is going to give us. So I'm going to give you a table, and we're going to figure out the other values that complete this table. And then we're going to type in our graph right next to the table. I'm going to pull up my virtual TI, so we can use that to kind of help us here. So when you're graphing these equations, you're going to go to use your calculator. You're going to hit y equals there on the top left, and you're going to clear out whatever's in there. So now I'm going to enter in my equation. I have x, and remember to get that to the third power, you hit caret third plus 6x squared plus 9x. I'm just going to click graph, and there's the graph of my polynomial. If you don't see this on your screen, you can hit zoom and then number 6, and it'll give you the window that I have. So now I kind of have a sense of what my graph is going to look like, but I want to get some points down that I can get the best representation of my graph as I can. So remember, to get the table, you hit second graph, and it gives you a table of values. And I'm just going to start where my x value started there. So when -4 is entered in as an x value, -4 comes out. Then -3, 0, -2, -2, -1, -4, and 0, 0. So now I can plot those points, -4, -4, -3, 0, -2, -2, -1, -4, and 0, 0. Clicking graph again, I can get a sense of what my graph is supposed to look like. Okay, so from there we can identify some of the key features of our graph. Okay, so domain was all of our possible x values. And in this polynomial, the domain is going on forever in both directions on the x-axis. So this is going to be familiar, hopefully. The domain is -infinity to infinity, because it goes on forever in both directions. And the range actually winds up being the same as well. Also -infinity to infinity, because this is going on up and down forever in both directions. For my zeros, or my x-intercepts, there's only one x, actually there are two x-intercepts here. It's where it's crossing on the x-axis. I'm just going to label it there. There's a 0, and there's a 0, or your x-intercept. So you just have to label the coordinates of those. So here we have -3, 0, and 0, 0. Those are my two zeros. All right, the last piece for today that's new is called the decreasing interval. And then increasing interval. So decreasing interval is when you're on this graph, where is the graph decreasing as you're moving along the x values? So the graph is decreasing here, and I'm going to use a highlighter, from -3 to -1 in terms of the x value. So again, you're only looking at the x values when you're looking at your decreasing and increasing intervals. So decreasing interval there is the blue section, and for my x values, that goes from -3 to -1. So my decreasing interval is -3, -1. That's where it's decreasing for the x values. Increasing interval is the same idea, where you look at the x values. But now we're looking at where is the graph growing. So I'm going to highlight this in yellow. So here's where it's positive, and positive, because I'm going up in those areas. So from here, I'm increasing from negative infinity up to negative 3 for the x value. And you use this U symbol as like a union because it also is going to be increasing from negative 1 to infinity. So the trickiest parts of these is remembering you're looking at the x values where things are increasing. So what are the x values of where the graph is growing or decreasing when you're doing increasing and decreasing intervals? Let's take a look at one more equation so you have another example in your notes to reference to help you with any of the problems that you might be working on. Okay, so number 2. It's going to be y equals x cubed minus 3x plus 2. And for the table of values, we're going to do x, y, and we're going to start at negative 2. From negative 2 to 2. And we'll tape this one in there. Remember to make sure to have your graph with the y facing up. Okay, so same thing. I'm going to bring up my calculator. Hit y equals. Turn it on first. Hit y equals. We'll clear out the old one. I'm going to type in my new equation. X to the third minus 3x plus 2. Hit graph so I can get a sense of what it looks like. Second graph to get the table, and I'm starting at negative 2. So starting at negative 2, my output is 0, then 4, 2, 0, 4. So I can graph those points, negative 2, 0, negative 1, 4, 0, 2, 1, 0, 2, 4. And then clicking graph again, I can get a sense of what my graph looks like. So there's my polynomial. Okay, so we can identify some key features really quick. Domain and range are easy because those are the same that we've been seeing in the other example. Domain is negative infinity to infinity, and range is negative infinity to infinity as the graph goes on in both directions forever. The zeros, there's 2 of them again. Where it's crossing on the x-axis, I've got negative 2 comma 0 and 1 comma 0. And you can see those in the table as well. Where is the graph decreasing? Again, we look at the x values of these points. So I'm going from negative 1 to 1. And then where is it increasing? Again, you want to look at the x values. So it looks like I'm going from negative infinity to negative 1, union 1 to infinity.